Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from probability and statistics. The question belongs to paper 9709/51 for the session May June 24. And we are going to solve question number 4 today, which says a game for two players is played using a fair four-sided dice with sides numbered 1, 2, 3, and 4. One turn consists of throwing the dice repeatedly up to a maximum of 3 times. When a4 is obtained, no further throws are made during the turn. A player who obtains a 4 on their turn scores 1 point. Question number A says, show that the probability that a player obtains a4 in one turn is 37 over 64. So let's start the solution. So from the question, we have come to know that whenever a player obtains 4, no turn, no further turn, not over here, it is written over here. When a 4 is obtained, no further throws are made during the turn. So such cases are called geometric distribution. Whenever the desired score is done and no more experiment is done after the desired score, it is called geometric distribution. So easy way to identify a geometric distribution is whenever a desired score is obtained or desired success is obtained, then no more experiment occurs. Such cases are called geometric distribution. So let's start writing as geometric distribution. So x belongs to geometric distribution and a parameter sorry, and the parameter for geometric distribution is nothing but the success. So success is total, there are 4 numbers. Okay, out of 4 we require only 4, so 1 over 4, 1 over 4 is our success. So parameter of geometric distribution is nothing but success. But at the same time, unsuccess is also sometimes required. That's why success is denoted as p. We will denote p as success. P is equal to 1 over 4, and q will be denoted, q will denote unsuccess. Unsuccess means 3 times he failed, so it will be 3 over 4. So success is 1 over 4 and unsuccess is 3 over 4, which are symbolized by p and q. So let's see the scenario. They have told to find the probability when x is less than or 3 times, because they didn't mention that on the third trial he succeeded or on the second trial he succeeded. They told it was less than. Look at this, a player who obtains, here it is written, show that the probability that a player obtains a 4 in one turn means actually 3 throws. Look, throwing dice repeatedly up to a maximum of 3 times. So throwing 3 times is actually one turn. Let me erase this unnecessary lining. So the player might take 3 throws, he might take 2 throws, he might take 1 throws, we don't know. In such cases, we can write this probability of x less than 3 throws, less than or equal to 3 throws. So the formula for such cases is, 1 minus unsuccess. That means total probability is 1. From total probability we will find how many times he might fail. So he might fail how many times? Out of 3 times, somewhere he succeeded. So the answer is going to be 1 minus 3 raised to 3 is 27. 27 over 64. If we simplify the answer, it is going to be 37 over 64. And they have told to show this answer. We have showed. So what is the formula? We don't know when he succeeded, but among 3 trials, he might succeed in the first trial or second trial or third trial in such geometric distribution, the formula is 1 minus q raised to total number of experiment. So total number of experiment is 3, and among these 3, all 3 are not actually failure. Somewhere he succeeded. So the formula is 1 minus q raised to number of experiment. I think you have understood. Let's move on to the next question. The next question says Zeno and Yao play this game. Find the probability that neither Zeno nor Yao score any points in the first two turns. So, for your kind information, actually one turn, success in one turn is just obtained from the previous one. Look at this. This is actually the of success in one turn. 37 over 65. Now this is about two turns. Okay, so it will be two times. Now let's write the scenario. Scenario is probability nor home zeno into probability of nor yao. Now you may ask a question that what is the necessity of multiplication in between them. Actually, the probability, they told that Zeno and Yao together, and look at this, and is the clue word. Whenever and is mentioned, then probabilities are always multiplied with each other. If or is, this is simple concept, if or is there, then we would have done addition. So and equal to multiplication, or is equal to addition. Here Zeno and Yao, both of them are playing together, that's why it is multiplication, and is the clue word. Well, nor Zeno. For success, for success, their probability of success is 37 over 64, but here it is unsuccess, failure. So failure is going to be 27 over 64. Well, but how many times he failed? Two times. Look at this. In the first two turns, in this is the probability success of one turn, but we are calculating for two turns. So unsuccess means q is two times. Same goes for, so is for Yao. Yao also failed two times. So the score is actually same. I mean probability is exactly same, 64, and he also failed two times. So here our P is actually, P was what? 37 over 64, and Q, I mean failure, was 27 over 64. Now look at this, both of them failed in both the experiments of both the trials, so it is actually failure. First Zeno failed two times, that's why this is the probability, and then Yao also failed two times, that's why it's all about unsuccess, not success. So ultimately if we calculate this, we will find that this, let me calculate using my calculator. 27 over 64, it's total four times, equal to 0.0317. 0.0317. I think you have understood the explanation of this question. Yet if you have any confusion, let me clarify this through comment. You can let me inform that. Let's move on to the immediate next question. Question number C says Zeno and Yao each have three turns. Find the probability that Zeno scores two more points than Yao. We should not forget that it's no more geometric distribution any longer. This is nothing but binomial distribution. How did we understand? We understood that the total number of experiment is three turns. Total number of experiment is given. In such cases, when total number of experiment is given, then it is nothing but binomial distribution. So let us write x belongs to binomial distribution, and the parameters for binomial distribution are total number of experiment is 3, and probability we have come to know the from the previous question, it's 37 over 64. Well, now both of them have played together. So first Zeno and the second player is Yao. Well, they told that Zeno scored two more times. Suppose Zeno succeeded three times, so Yao succeeded once, because the difference between the success times should be two. And there may be another option that Zeno might succeed two times and Yao failed every time. So how to write this? Let us write with a different ink. Well, so if Zeno succeeded three times, we have already decided this is a binomial distribution. So for binomial distribution, out of three for Zeno, three choose three. All three times he succeeded, and the probability of success is 37 over 64. He succeeded all three times. Then how many times did he fail? He failed for no time, which is 27 over 64. That is, he failed zero times. Zero times. Well, this is for Zeno. As they are together playing the game, so there will be multiplication. Here it is 0. Then for Yao it is going to be out of three experiments he succeeded once. So it is going to be 3 choose 1. He succeeded 1, which is 37 over 64 once. It is once. That means rest two times he failed. So it is 27 over 64. How many times? Once. I mean, one success, two times failure. Then if we simplify this, 3 choose 3 is actually 1. The value of 3 factorial over 3 factorial, it is 1, so we don't need to calculate this. Then 37, how many times? Here 3 times, here 1, so 37 is 4 times. 64 is also 4 times, so we can write 37 over 64 4 times. Okay, let's see 27 here 2 times, here 0 times, so it is 2 times 27, 2 times 64 is also 2 times, raised to 2. Now let's see, we have already calculated 3 choose 3 is actually 1, so it is unnecessary to be multiplied. But 3 choose 1 is not 1, it is actually 3. 3 choose 1, I clarified this for how to calculate this factorial problem. 3 choose, that means if 1 is chosen out of 3, it will take 3 times. Then for the second case was Zeno succeeded 2 times. So 3 choose 2 times. So success is 37 over 64 2 times, and once he failed. So 27 over 64 is failure. After that, for Yao, he succeeded for no time. So for Yao, it is going to be 3 choose. Out of 3 chances, he succeeded 0 times. So success is 0 times. 37 over 64 is 0, and failure is 3 times. 27 over 64 is 3 times. So let us calculate this. 3 choose 2 is also 3. You know how to calculate this. 3 choose 2 is actually 2. Sorry, 3. 3 choose 2 is 3. So 3 into 37, how many times? 37 2 times. So 37 over 64, it is 2 times. And 27, how many times? Here once, and here 3 times. So it is going to be 27 over 64 is 3 times. Well, here once, here thrice, so 4 times. Now 3 choose 0. 3 choose 0 is also 1, because 3 factorial divided by 3 factorial is 1. Now let's calculate them individually. We will write hence probability is equal to probability probability, the final probability is going to be probability is equal to, first this one was our question. Okay, if we calculate this 37 over 64, how many times? It is 4 times, and 27 over 64 2 times, 2 times into 3, let me write this 3 in the beginning here. Let me erase some parts so that I can write well. So here we will write 3 into this, and plus for the second case. Second case was 3 into 37 over 64. 37 over 64, how many times? 37 over 64 is 2 times, 2 times, and 27 over 64 will be 27 over 64 is going to be 4 times. 27 over 64 is 4 times. Well, then ultimately our probability is going to be, let me write just beside this and zoom it in. Let me erase this. So if we zoom it in, our probability is going to be, let me use my calculator. It is going to be 3 into 37 over 64 raised to 4 into 27 over 64 raised to 2 plus 3 into 37 over 64 raised to 2 into 27 over 62 raised to 4 equal to 0.0914. Okay, point 0.91 and 4. I don't have space to complete the writing. Can I write just below this? Equal to, it is, it was 4, equal to 0.099141 and 4. That is our answer. The probability of scoring, Zeno scoring 2 more times than Yao. I think you have understood the question as I have explained. Still, if there is any clarification necessary for you, please let me know. Fi amanillah.